Hello everyone, my name is S Venkata Sai Sashank and I am currently pursuing my BTech degree in the stream of Artificial Intelligence in Amrita Vishwavidyapitham Amaravati. My roll number is 23043. Today I am excited to take you through a fundamental topic in programming, immutable sets and maps. These are powerful concepts that help you write safer, easier, more efficient and bug-free code. So let's dive in and explore what immutability is and how immutability maps and sets work and why they are so useful in software development. Let's get started. Welcome to this presentation on immutable sets and maps. Today, we will explore the concept of immutability in programming, understand what immutability sets and maps are, and dive into their key operations and use cases. Here our agenda for today. We will start with an introduction to immutability, then discuss immutable sets and their operations, followed by their use cases. Next, we will move on to immutable maps, look at their operations and use cases. And finally, we will wrap up with a practical demo and a conclusion. Imagine you have a collection of data that you want to keep constant without any accidental changes. This is where immutability comes into play. In programming, immutability means that once you create an object like string, number, or data structure, it cannot be changed. Any modification results in creating a new object rather than altering the original one. An immutable set is that once created cannot be changed. Think of it like a bag with a few unique elements in it. In a regular mutable set, you can add or remove items at will. But with an immutable set, the items are fixed. Once you put them there, you cannot add or remove anything. Let's go through some key operations of immutable sets. First, you can create an immutable set and specify its elements, which remain constant. You can check if an item exists in a set using a simple in keyword. The union operation combines elements from two sets, creating a new immutable set with unique elements. Intersection finds common elements and difference provides items in one set but not in the other. Lastly, we can get the count of items in the set. Immutable set has various use cases. For instance, they provide data safety as they can't be modified accidentally, which is useful for sensitive data. They are easier to debug since they won't change unexpectedly, and they are thread safe, meaning they can be used across different threads without risk of conflicts. Immutable sets also offer predictable behavior and also sometimes improve performance in heavy tasks. Now let's move on to immutable maps. An immutable map is like a regular map or dictionary that cannot be modified once created. Think of it as a phone book with names as keys and phone numbers as values. Once you create an immutable map, the data in it is locked and any changes require creating a new map which prevents accidental modifications. Key operations of immutable maps include accessing value by their keys, checking if a value exists, and retrieving all keys or values. To add or update a key value pair, you create a new map with the changes. Similarly, removing a key results in a new map without that key. Lastly, you can get the length or the number of key value pairs in the map. Immutable maps are beneficial for data consistency and safety, as they prevent unintended modifications. They make debugging easier by reducing unexpected changes and are thread safe, making them reliable in concurrent programming. They offer predictable behavior which simplifies code maintenance and may also be optimized for ready heavy tasks, improving performance. Let's dive into a practical demo where we will create and work with immutable sets and maps. We will go through creating these collections and performing some of the key operations we have discussed. This code demonstrates how to work with an immutable set in Java, using various operations like creation, checking for an item, union, intersection, difference, and getting the size of the set. Let's go through it step by step. First, we create a regular hash set called original set and add three items to it: apple, banana, and cherry. To make this set immutable, meaning it cannot be changed, we wrap up with a collections.unmodifiable set. We're creating a new set called immutable set. Now, immutable set is fixed set that we can't modify, so any attempt to add or remove items will result in an error. Next, we want to see if a specific item is in the set. Here, we check if banana is in the immutable set using the contains method, which results true or false. Now, let's do an union operation. This combines all unique items from the two sets. We create a new set called other set with items banana and dragon fruit. To create the union, we copy all the items from immutable set into a new set called union set and add all items from other set as well. Then we make union set immutable by wrapping it with collections.unmodifiable set. So you can see here we made it as unmodifiable set of union set. Then the result is an immutable set containing all unique items from both sides. Next is the intersection operation, which finds items common to both sets. We start with a copy of immutable set in intersection set, then use retain all to keep only the items that are also in the other set. We make intersection set immutable and the result shows only the common items between the two sets. The difference operation finds items that are in the immutable set but not in the other set. We start with a copy of immutable set in different set and use remove all to remove any item found in other set. We then make different set immutable. The result in an immutable set containing only the items unique to the first set. Finally, we get the length of the immutable set, which is simply the count of items in it. Use the size method to do this, which tells us how many items are there in the set. This is the output for immutable maps. Firstly, it is the immutable set. Apple, cherry, and banana are contained in it. Is banana is contained in it, it will return true. The union of sets: apple, cherry, dragon fruit, banana. Intersection of sets: in both sets, banana is the common element. Difference of two sets: apple and cherry. Length of the immutable set is 3. This Java code demonstrates how to work with an immutable map. We will through various operations like creation, assessing a value by key, checking if a key exists, getting all keys and values, creating new maps with added or removed keys, and getting the map size. And let's dive in. First, we create a regular hash map called original map and add some key value pairs like name, age, and city. Then to make this map immutable, we wrap up with collections.unmodifiable map and store it in immutable map. This makes immutable map a fixed, unchangeable map, so any attempt to modify it, it will result in an error. Next, we can access values in the map by using keys. Here we get the value for the key name from immutable map. This returns alias, which is the value we set for the key. Checking if a key exists. We can also check if a key exists in the map. In this example, we check if the key is present. Key age is present in immutable map, which will return true. To retrieve all the keys in the map, we use the keySet method. This returns a set of all keys like name, age, and city. We can also retrieve all values in the map by using the values method. This returns a collection of all values like Alice, 30, and Wonderland. Now let's say we want to add a new key value pair to the map. Since immutable map itself can't be modified, we create a new hash map based on immutable map and add new key country with the value Wonderland. Then we wrap this new map with collections.unmodifiable map to make it immutable again, creating immutable new map. Similarly, if we want to remove a key, we create a new hash map based on immutable map and remove the key city. Then we wrap this modified app in collections unmodifiable map to make it immutable again, creating immutable after removal, getting the length of the immutable map. Finally, we can get the size of the immutable map, which is simply the number of key value pairs present in it. Here we use the size method to find out how many items are there in immutable map. This is the first immutable map. City Wonderland is 30, name Alice. Value for the name is Alice. Is age keys content, it will return true. Keys in the map are city, age, and name. Values in the map Wonderland 30 Alice. New map with added key. Country Wonderland, City Wonderland, age 30, name Alice. Map after removing city, age 30, name Alice. Length of the immutable map is 3. Real world applications of immutable sets. User permissions. Immutable sets can store a list of permissions assigned to a user, ensuring these permissions aren't altered accidentally during a session. Configuration flags. Immutable sets of configuration flags ensure that application settings remain consistent throughout the runtime. Unique queue identifiers. Systems like vehicle registration departments use immutable sets to store unique queue identifiers. Example, license plate numbers. To prevent duplication and maintain integrity. Category and tags. An immutable set of categories for a block or tags for a content management system, preventing accidental changes to predefined categories or tags. Product serial numbers. Immutable sets can store product serial numbers in a manufacturing system to prevent modifications after initial entry, ensuring product traceability. Access control list. In secure systems, an immutable set of allowed IP addresses or users ensures that access is restricted without accidental modification. Real-world applications of maps. Environment configuration in software development. Immutable maps store configuration settings, example database URLs, API keys, to prevent accidental changes during application runtime, ensuring consistent deployment environments. Country codes and currency codes. An immutable map for a country and currency codes in financial systems to avoid issue for accidental edits and ensures data accuracy in international transactions. Exchange read data. Financial applications use immutable maps to store exchange rates for a specific period, ensuring transactions use consistent values. Translation dictionaries. Immutable maps store translation for multilingual applications, providing a stable reference for text in different languages without the risk of accidental modification. System error codes. An immutable map of error codes and messages ensures that error responses are consistent and unchangeable in critical applications. Application constants. In web applications, immutable maps are used to store constants like status code or fixed URLs, providing predictable references across the application. Conclusion. Immutable sets and maps are valuable tools in programming. They offer stability, safety, and predictability by ensuring that data remains constant after creation. This prevents accidental modifications, simplifies debugging, and helps ensure consistency across your code. Thanks for you watching. Thank you for watching, and I hope this presentation gave you a clear understanding of immutable sets and maps.